Yeah, hello everyone, and thanks for having me. My name is Andreas Muller. I'm the head of communication and network technology in Bosch Corporate Research, based in Stuttgart, Germany, and at the same time, the general chair of 5G ACIA, the 5G Alliance for Connected Industries and Automation. But as you can see from my slides, this will be a Bosch presentation. And I have the pleasure to talk about the question whether or not vertical industries actually need 6G. But before talking about 6G, let's have a brief reality check of 5G. So here on the left-hand side, you basically can see the vision that all of us had in mind with 5G. So 5G is about vertical industries, unlocking new application areas for mobile communications, be it industrial automation, automotive, self-driving cars, healthcare, or agriculture. So this is basically what we had in mind with 5G from the very beginning. But if we see where we are today, then it looks more like this. So basically 5G, as of today, is primarily a consumer business. It's used for connecting smartphones, for mobile internet access, and that's basically not very different from what we had with 4G before. So the question is, why is it like this? Was it just overhyped? Was maybe this vision of having the verticals part of the 5G ecosystem, was this something that did not work out at the end? Or why don't we see a more widespread adoption of 5G in different vertical domains yet? And there are a couple of reasons for this. Some of them are shown here. So first of all, the verticals started rather late. Organizations like 5G ACIA have been established only in 2018. So a couple of years later than the start of the research activities towards 5G. And then, of course, the verticals have to catch up and they have to start from scratch, and this simply takes time. Also, some of the features that make a difference to many vertical domains come only with later versions of the standard. What we have in reality today is release 15, of course, but it starts to get interesting in many cases with release 16, and maybe in some cases even only release 17. In release 16, for example, we will get ultra-reliable latency communication, time-sensitive networking, and similar aspects, which are then very attractive, for instance, for the manufacturing industry. Also, business cases are concerned here, so it's not so straightforward to come up with a strong business case. 5G per se is not a use case, and also not a business case, so we have to see what can we do with it. And also we have to find adequate pricing and a sweet spot, basically, with the pricing so that it's attractive enough for everyone. And that also takes time to explore this. The same is true for the device ecosystem, which has to build up from scratch. So we need not just chipsets and infrastructure components, we need also special vertical components like robots or automated guided vehicles manufacturing, integrating then 5G. And also it takes more than just new KPIs, so more than just lower latency, high reliability of the interface and so on. We need also more system aspects like non-public networks, private networks. We need new business models for charging this, new ways to deal with service level agreements because we have more demanding requirements and expectations. And all these things take time to discuss and to establish this. So therefore, it's, to me at least, not very surprising that we are not really there yet with 5G, but it also shows that there's still some way ahead with 5G before we can really then think about using 6G in reality. So, but still the question is, do we really need 6G? And does it make sense now to start research activities on 6G already? And from my perspective, the answer is certainly yes, because we need 6G alone to be able to deliver on the full 5G promise. So then we also see that 6G may bring additional value from additional features, for example, integrated sensing and aspects like this. And this might be very interesting and relevant, especially for vertical industries. I will get back to that later on. Also, 6G is an opportunity to really have a more holistic view on things and to perform a more holistic optimization. With 5G, we were still focusing a lot on the communication system per se, and we try to make it really good and to achieve a very good performance. But in order to get the maximum value out of all this, we really should have a holistic view on things, which includes the communication system, but also the actual applications and the actual domain management systems, whatever that means. And of course, we also need 6G because the verticals won't go away anymore. So we are now part of 5G. We are eager to use 5G in our domains. And then, of course, we won't switch back to any other technology, but then we also want to have 6G at some point. But we have to make sure that we get things done in the right way. So what does it take for another G? Well, it's something you hear very often, right? So basically, if you look back at the past, it takes about 10 years and at least a 10x improvement compared to what we had with the previous generations. And then it's rather straightforward to define some target KPIs, target requirements. We just take the target KPIs of 5G, and then we take an at least 10x improvement so that we end up with a target peak data rate of 1 terabit per second, maybe latency in the order of 100 microseconds, and maybe 25 years battery lifetime would be a good number. So that's the usual way, and that's what we see, what is happening. But I'm really not sure if that's all and if this is the right way, right? So in the past, it was a little bit like this, when we still had a strong focus, especially on data rate, and we could say, okay, 10x or maybe even more than that improvement in data rate is the next evolutionary step. But now it's a different thing. Now we have all these vertical industries, the vertical applications, not only data rate matters, also other aspects. But before we just extrapolate now and say, okay, latency should be 0.1 milliseconds, we always have to question ourselves, why are we doing this? And we have to understand the entire system and understand if there is really a need to have this. And in some cases, also for the parameters that are listed here, I'm not really sure if these are the most critical aspects if you look at 6G. So what does really matter then? What are major trends and drivers towards 6G from the perspective of a vertical player like Bosch? But I think we are very well aligned here with many companies in the industry. So first of all, the vertical industries should come first. What does this mean? If we look at standardization today in 3GPP, for instance, only very few vertical players are directly engaged. And that's simply because it's a lot of effort, a lot of work, a lot of traveling. You need a back office to support delegates. But at the end of the day, as a vertical player, only a fraction of the topics that is being discussed is usually of interest to you. Because for us, 5G and in future 6G is just a part of our business. It's one building block, apart from many other building blocks that we have to understand and to master, but it's not part of our core business. And that's, of course, why we cannot invest as many resources as the classical telco players can do. What we did with 5G in order to address this problem a little bit is we established all these 5G associations, be it 5G ACIA for the industrial domain, 5G AA for automotive, and so on. And this helps because these associations provide a forum to get all the relevant players together, and then also somehow a shortcut for the vertical players to bring in their requirements and use cases to 3GPP via the ICT industry or the big vertical players that have a presence and a footprint in 3GPP themselves. However, there's still some challenges. I mean, it's something that works okay, but maybe not the optimal setting. Vertical associations cannot really directly contribute to 3GPP. Even as a market representation partner, the contributions still have to come from the member companies, the member organizations, and that makes then the vertical players very much dependent on the goodwill of others. And it's something that is maybe not desirable. And also, of course, the verticals are not directly part of the discussions. And in the discussions, many things are really developed then that make it into the standard. So therefore, we really should think about the way we are doing things. Just because we've always been doing things like this should not be reason that we still have to do it like this if we look at 6G. So 3GPP has been established for standardizing a classical public network for the classical consumer business. The major stakeholders are network operators, infrastructure vendors, chipset manufacturers, and so on. So big companies, for all of them, 5G mobile communications is their core business. And for them, this works quite okay. But now with the vertical players, it's a different thing. They should be in the driver's seat because that's one of the main reasons why we are working on 6G at some point. And therefore, we should also rethink the way we are doing standards here. I know it's very difficult to change 3GPP, but simply because it's difficult, we should not start doing it. So then, if we look into many of these vertical domains, right? In many cases, what we require is local connectivity in a very controlled environment in some way or one way or the other. So this is true for manufacturing, but it's also true for agriculture, for some infrastructure-assisted automated driving applications, construction, healthcare, transportation hubs, and so on. So we really need only local connectivity. Automotive is maybe an exception, so there we need really widespread coverage. But for the majority of application domains, it's all about local connectivity. And local connectivity with special requirements in terms of performance, in terms of security, and that's why there's such a high demand for private networks, for non-public networks, and this should not change with 6G, but rather these private networks, non-public networks should become even more in the focus of all the activities. So maybe a 6G network at the end of the day is not comparable anymore to a 5G network today, which is still dominated by the public networks, and then there's some islands basically in a factory here or in a hospital there with a private network, but it's more the other way around, so that we have really many of these tailored networks, special purpose networks for different vertical applications, but typically focusing on local context. And then they are connected if it makes sense in one way or the other, and this basically forms then what we may call 6G at some point in time. So that 6G is more really a network of non-public networks. And of course, we have the regulatory developments in various countries which put aside some spectrum for enterprises, for these vertical applications, like we have it in Germany, in the United Kingdom, in the United States with CBRS. In Japan, we have local spectrum available. So this is really now gaining a lot of momentum, and this helps to support these developments towards non-public networks. And again, from my point of view, this will really become and has to become to get into the center point of the considerations with 6G. Then what we also see happening today already is the development towards Open RAN, so that we get away from this traditionally rather closed systems in the RAN, proprietary hardware and proprietary software, to highly modular, disaggregated, virtualized systems with open interfaces and APIs. So it's not something that will be very new, or we don't have to wait 5 years until we see this. That's happening today with 5G and even the previous generations. But this is something that should be considered now with 6G from day one, from the very beginning, that we think along the lines of the Open RAN vision, with the potential then to bring the costs down. And that's again beneficial because it helps us in finding and defining the right business cases. It provides a lot of potential then also for an optimization and tailoring of infrastructure components, for example, for specific vertical domains. It's very heterogeneous. There should not be one infrastructure that then includes all the features that are needed for manufacturing, for agriculture, for healthcare, and so on. But if we have a very modular system, a software-defined system, then we can really easily come up with very specific solutions for the different domains. And again, this may also lead then to a cost reduction. And also this may simplify management and operations, also with things like the RIC in O-RAN, so that we can couple also the management of a radio network, of a radio access network, with the management of the production, for example, manufacturing or other domain management systems. So in general, we see the combination of Open RAN with non-public networks as a very interesting approach and a perfect couple basically for many local vertical applications. Now, one of the really new things that is very interesting from our perspective is the development towards higher frequencies. Of course, also this started already with 5G, where we moved to the millimeter wave range. But if you now look at terahertz spectrum, and maybe starting with the sub-terahertz range, 100 to 300 gigahertz, there's a lot of potential and many promises that we see. It's a large bandwidth that is available for supporting the high data rate that we need in many cases, and in future we need it even more than today, but also then the potential for highly accurate positioning. Of course, especially these very high frequencies are primarily suitable for local applications, so this fits to what I've said before. This provides intrinsic security. Jamming make it very important if I use a terahertz system inside a building, and at the same time eavesdropping on the data may become very challenging outside of the building without any encryption, basically. Of course, we still will use encryption and things like this, but we have some intrinsic security that we can realize this way. But maybe the biggest promise, of course, are these novel secondary applications that may be realized at these very high frequencies, be it integrated radar, using it for material inspection in manufacturing, for imaging, for activity detection, gesture recognition in a car, for example. So this may provide a significant value add, especially in many different verticals, which is very attractive, very interesting. And again, this may help to come up with sustainable business cases at the end. So one of the last things that I would like to highlight is really the costs of the system, right? We have this shift, if you look at the verticals, from a B2C business to a B2B business, but it means also we have a shift from a more emotional buying behavior. I think everybody knows what I'm talking about, to a strictly ROI-driven investment decision. So no one, whether be the factory owner or farmer, will deploy a 5G network in future 6G network just because it's nice to have one. We really have to see a positive return on invest, and we can work on the return side. So new features like integrated sensing can help here, but we also have to work on the invest side and basically try all our best to bring the total cost of ownership down. And from the very beginning, this should be a major design criterion. And I would say this has not always been like this in the past if you look at the previous generations. So the different ways to bring the TCO down, we will very quickly go over this slide here. So it starts with the infrastructure. I mentioned some things already. So this modularity, if it's all software defined, if we have Open RAN at its heart, so then it should be rather straightforward to tailor the equipment, for example, to the needs and to bring infrastructure costs down. The same for the devices, for the chipsets. So that we also have maybe new things like a dynamic feature activation. I don't have to pay all the features, have to pay for all the features that the chipset supports, simply because it's in the silicon, but I only pay for what I need. So that's more changed on the business model side. Also, the operations should be significantly simplified with network automation, extensive usage of artificial intelligence, especially the operation then of private networks. We also have to think about patents and how to deal with this. So this is getting more and more a concern for many vertical players because the telco industry traditionally is a little bit more aggressive with respect to patents than the situation that we have in these vertical domains. So we could also think about how to make sure that the risk that is associated with this is manageable by the vertical players without leading to extensive costs. And also energy consumption, of course, is something that needs to be considered from the very beginning. And here again, the non-public networks may help, but also this cloudification and so on, centralization of things may certainly help as well. And then last thing that I would like to highlight is what I mentioned already at the beginning. So we really should start to have a holistic view on systems, on things. With 5G, we basically started trying to make 5G as good as a cable in many cases, right? So if you look at manufacturing again, which I'm most familiar with, we try to support the same cycle times, the same latencies, the same reliability that we have with a cable today. And it's basically a fair approach because then the integration and the migration is very simple, but it's not necessarily the optimum from a system perspective. In order to improve things here, we need a holistic view. That means a whole joint optimization of the application with the communication system. And this is true for the user plane, but also for the management plane. So to just give two examples, I'm thinking about things like network control systems. So where we don't have this strict cyclic communication necessarily. Maybe it's also more event-triggered control, where the application knows that there can be some errors or some delays on a communication link. So we can basically also adjust this a little bit. And also with the management, so that we have a joint management of the systems. For example, in the factory, we know where things are driving, where a forklift is driving. We know where an HEV, an automated guided vehicle, will be driving to. And then we can somehow predict with 100% accuracy that an automated guided vehicle will block the signal between a mobile robot and a base station. So that's something we can really predict. And of course, something we can take into account. If we couple the management systems for the network and the production management. So a lot of potential that may be unlocked here. And at the end of the day, if we do it like this may even lead to relaxed requirements. So therefore, we do not necessarily need a 10x improvement in all cases. We first of all have to understand the overall system. We have to understand how we can optimize this. And at the end of the day, maybe the requirements get even relaxed. And of course, we are doing this because we want to bring the costs down. And this should be considered from day one. So that's my brief summary, basically, of what I've just said. What matters if you look at 6G from our perspective. So vertical industries should come first. The private networks, non-public networks should be in the focus from the very beginning. The same is true for the optimization of the total cost of ownership. The new features are very interesting, so it's really worth to spend quite some time and effort on those. Integrated sensing, terahertz, and all that comes along with this. And this holistic view from day one is important as well, to not optimize only the communication system, but really the overall system. With that, I'm at the end of my presentation. Thanks a lot again for having me, and it was a pleasure to be part of this interesting event today. Thank you.